Welcome guys to today's class. In this video, we want to discuss resistance and resistor. These are one of the popular terms we have in the topic electricity. Now, what does resistance mean? When you hear the word resistance, what does it mean? Resistance simply means opposition to the flow of electric current. Now, resistors simply mean substances or materials that opposes the flow of electric current. Okay, in this video we want to see how to calculate effective resistance of a given or of given resistors. And after knowing how to do the calculation, we need to learn other things concerning it. Let's see. We have three circuit diagram here, and it is noted that we have two possible ways resistors can be arranged. That is, it can be arranged in parallel, it can be arranged in series. In this third one is a combination of series and parallel. Now, whenever a resistor is said to be arranged in parallel, look at what we mean. It means it looks possibly in this way. This is a typical example of resistors arranged in parallel. Now, it is important to note that when you calculate the effective resistances of these resistors, when you calculate it and you get your answer to be maybe RT equals to X, let's say the effective resistance of resistors here is RT equal to X. That is, let's say the answer is X. That X must be less than the lowest resistor, which is 5. If it is not less than 5, that means you are wrong. Now, another point you want to know is that when you see resistors arranged in parallel this way, that means they will be having different current. That is, current for this one will be I1, this one I2, this one I3. They will be having different current, but with same voltage. Please note it. When you have resistors in parallel, that simply means they will have different currents with same voltage. Note it. Now, in Ohm's law, it is noted that Ohm's law states that V is equals to IR. Current times resistor will give you voltage or potential difference. Please also note this. Now, let's see how to resolve these three resistors that are in parallel to get their effective resistances. Now, let's see how to calculate the effective resistances of these resistors arranged in parallel. Look at the formula. 1 over RT, where RT is the effective resistance of the resistors, equals to 1 over R1 plus 1 over R2 plus 1 over R3. Then R1 is the first one, 5, plus 1 over R2 is the second one, 10, plus 1 over R3 is the third one, 15. 1 over 5 will be giving you 0.2 plus 1 over 10, 0.1 plus 1 over 15 will be giving you 0.066, 0.067. Now you add up. Everything will be giving you 0.367 ohms. That is 1 over RT. Now, per ohm, please, that will be giving you That will be giving you 1 over RT equal to 0.367 per ohm. Now get your RT. RT will be, get the inverse of all this. The inverse is 2.72 ohms. So this is the effective resistance of the resistors you have here. That means the totality of this to get it, that means in the totality of this to get the effective resistance of it, will be giving you this. You can see it obey the rule that the answer must be less than 5 ohms. So we can call this your X. The answer must be less than 5 ohms. Correct. Now, assuming they ask you to get the voltage in 5 ohm, 10 ohm, and 15 ohm, tell them that the voltage of each, since V is equal to IR, what is your R? 2.72. You now say that V will be equal to I is 5 times 2.72. That is the total resistance, 2.72. So 2.72 times 5, that will be giving you 13.6 volts. That means the voltage here is 13.6, 13.6, 13.6. This is because when resistors are arranged in parallel, note that voltage is always arranged in parallel to the circuit. That is, the voltage, once you have voltage, the voltage will be the same for each of the resistors, because voltage is always arranged across the circuit, that is in parallel to the circuit. So each of these resistors will be having same voltage. Because this is in parallel, the voltage is also arranged in parallel to the circuit, that is across the circuit. Now that makes V is 13.6, 13.6, 13.6 volts. What about the current? Current passing to this. Since we say it will have same voltage but different current, the first current will be I1, R1. Then the next current, therefore, I1 will be equal to V over R1. That is, V is 13.6 all over what? 5 ampere. 13.6 over 5 ampere is the current for I1. For I2, V equals to I2 R2, because they will have the same voltage but different current and different resistor. Therefore, I2 will be equal to V over R2. That is equal to 13.6 all over 10 amperes. Then I3 R3. Therefore, I3 will be equal to V over R3. That is 13.6 all over 15 watt ampere. So these are the currents passing through each of the resistors. Since they have different currents, you can see these values are different. They will have different current as well. Okay, if you add up all this current, it will be giving you approximately 5 amperes. That is equal to the total current we have, which is 5 amperes. We come to this. Now, to solve the second circuit, this is what we mean by resistors being arranged in series. That means this current that is moving up now, it will be seen by each of these resistors. That is, each resistor will be seeing the same current. They will be seeing the same current. But for the voltage, they will be seeing different voltage. That is resistors arranged in series. They will have same current but different voltages. Point number one. Now, when you get the effective resistance of these resistors arranged in series, it is noted that their effective resistance will be greater than the highest resistance, which is 50 ohms. The effective resistance will be higher than it. That is point number one. Point number two is that this current will be seen by each of them. So they will have same current. They will have same current but different what? Voltages. That is number two. Now, since it is talking about electricity involving current, voltage, and resistor, it obeys Ohm's law, which said that V equal to I R. Let's get the effective resistance first of all. Now, when you talk about resistors arranged in parallel, the effective resistance will be add them up just like that. 5 times 10, 15, 15 plus. Now, when you are talking about resistors arranged in series and you are asked to calculate the effective resistance of it, what you do, you just add them up. 5 plus 10, 15, 15 plus 15, 30. 5 plus 10 plus 15, that is 30 ohms. That is the answer for effective resistance of resistors in series. Now, what you do is, do you notice that 30 ohms is higher than the highest resistor? Yes, that is why we say that RT will be greater than the highest. So 30 is greater than the highest, which is what? So you have to note that point. Another point is they have same current. So here we'll be having 5 ampere. It will be seeing 5 ampere, 5 ampere, 5 ampere. But the voltages will be different. V1, V2, V3. They will be having different voltages but the same current. And so, how can we calculate our voltage? Total voltage here will be equal to the I times RT. What is I? I is 5 times RT is 30. That is 150 volts. Now, we want to get the individual voltages in this circuit. First one, V1 will be equal to I R1. What is my I? I is 5 times, what is my R1? R1 is 5 ohms. That will be giving me 25 volts. 5 times 5 ohm will be giving me 25 volts. That is for voltage on the first resistor we have here. V2 equal to I R2 equals to I is what? 5 times R2 is what? 10. That will be giving me 50 volts. Then V3, that will be giving me I R3. Then 5 times 15, that is 75 volts. If you calculate the total of this, it will give you 150 volts. We are done with calculation of each of the resistors voltages. We are done with that, and we have noted their individual current, that it is constant for all of them. Yes, we now go to this question. In this question, I just want us to do the calculation of the effective. We now go to this question. In this question, we just want to see how to calculate the effective resistance of the resistors. See how to calculate the voltages, the current of each of the resistors. Let's see how to calculate the effective resistance. Now, let's say that current is moving this way. If current is moving this way, once you reach here, some will enter here and some will enter here. That means at this point, parallel will come in. These two are in what? Series. So this plus this will give me 25. That will make the circuit to look this way. Then we are here, this plus this is 25 ohms. We are here is 20 ohm. Then now these two are in parallel. We have to resolve it. Okay? How to resolve it? Like the first method. Since they are in parallel, 1 over RT equal to 1 over 20 plus 1 over 20. 1 over 20 is 0.05 plus 1 over 25 0.04. Therefore, 1 over RT is equal to this. If you add up this, it will give you equal to 0.09. Then RT will be giving you 1 over 0.09 divided by 0.09. That will be giving me 11.11 ohm. That is the total. You can see that this is less than the least resistor we have here, 20 ohm. Another way to do it is that we say RT will be 2 resistors, 20 times 25 over 20 plus 25. 20 times 25 is 400. 20 plus 25 is 45. So you just say 500 divided by 45 is 11.11 ohm. So that is another way you can do it if you have 2 resistors here. Then that means these 2 resistors have been compressed into one. So I will clean this side and write here to be 11.11 ohms. Whereas here still remain 5 ohms. You can see that when current is moving this way, if we get to this point, it will meet this resistor and meet this resistor in series way. At this, you can say it is in series. Therefore, final RT will be equal to this plus this, 5 plus 11.11. Final RT will be equal to 16.11 ohms. So that is how to resolve these resistors. Thanks for watching the video.